Right, so this is where we ended yesterday. This is pentane. This is 1-methyl butane. Oh, sorry, I'm wrong. It's 2-methyl. It's 2-methyl. Thank you. So because the carbon, the methyl group is on the second carbon.
But that one's 2, 2.
2,2
Yes.
methyl propane.
This one is 2, comma 2 dimethyl
propane.
Because it's a 3.
propane.
Mr. Nkuba, please can you come to body duty?
Okay, so, and the reason for that is there are 2 methyl groups. That's a methyl group. There are 2 methyl groups on the second carbon. Actually, these methyl groups don't have a choice. They can only go onto the second carbon. Because if they go onto the first carbon, it's 2-methyl butane again. If they go onto the third carbon, if one goes onto the third carbon, it's 2-methyl butane again. Okay? So you can't, it can't be anywhere else. Yes. Okay. We have identified that these molecules are non-polar.
Yes.
Non-polar molecules. Although there is a degree of polarity, the whole molecules outside are polarized positively. So this whole molecule is non-polar because to be polar it needs a positive part that's sticking out and a negative part that sticks out. You hear me when I say that?
Yes.
Okay. So the intermolecular force between these non-polar molecules are London forces. And we have it from last year that the London forces determines physical properties. The intermolecular forces determines physical properties.
Yes.
It determines a property like boiling point. That's what it determines. Are you with me? Okay. So we agree that all 3, the molecules that are on the screen now, are non-polar molecules. So all 3 molecules have London forces between them. Okay. Who will have the strongest London force? Because all 3 the molecules has the formula C5H12. That's the molecular formula. What's the molecular mass or the molar mass of the compound? It's 5 times
5 times
12 plus
12 plus 12.
another 12
So
times
72.
1. Okay, so what would you call the molar mass in this case?
Molecular.
Yes, but it's the same in every molecule. It is the controlled variable. It's the controlled variable. So all 3 the molecules will have the same molar mass, but they don't have the same melting and boiling points. So what does it mean? It means that the London forces don't have the same strength. So who will have the stronger
The
London
dimethyl
forces?
propane.
You say the 2,2-dimethyl propane.
Yeah.
Why?
I think it's the structure of I don't know how to.
Okay, let's think about it in a visible, in some, okay, yes?
Wouldn't it be the dimethylpropane because it's more condensed than the other one? Because the pentane, from the structure that it has, is more stretched out.
Yeah, you haven't, you're on the right track, but your thinking is not right.
Oh.
But
Wait now, let me explain it. What is the easiest? When is it the easiest to break the force between you and the earth? When you're on your feet or when you're on your bed?
When you're on your feet.
When you're lying down or when you're on your feet?
When you're on your feet.
What was your question?
When is it the easiest to break the force of attraction between you and the earth? When you're on your feet or when you're on your back?
when you're on your feet.
And you can just jump up.
On your feet, you just jump up.
Now, your contact with the earth is smaller when you're on your feet. If you're lying down on the earth, your contact, you're making more contact with the earth. So there are more places where the gravity is acting. I know it's a very stupid idea to explain it this way. Because a real physicist will say I'm completely on the wrong track. But I'm trying to visualize a situation. This molecule here, this molecule has much more contact area with other molecules of its kind. So there are much stronger forces of attraction. Those London forces are much stronger because these molecules are touching each other in more than one place. We say the surface area of the molecule is big. Bigger than this one. This one's surface area is slightly smaller because one of the carbon atoms took 3 hydrogens and joined as a side chain.
And that one has the
This molecule is nearly round. So it makes less contact with other molecules of its kind.
So, ma'am, the
So this
smaller
one,
the chain,
the shorter the
shorter
chain, yes,
the
the
less contact
smaller
force,
the
which means the
surface
surface
area, so the weaker the contact, the weaker the intermolecular forces. So this one has the smallest
chain.
surface area.
So ma'am, the top one is much easier to boil than the bottom.
No, more
The top one is
difficult.
more difficult. Stronger London force.
Stronger the forces.
Stronger
Oh,
forces, higher
stronger
boiling
forces are
point.
more difficult to break.
Yes,
Yes.
this one's got the stronger
Okay.
London forces. Sorry, I'm messing up the whole thing, but I need to write it there. So the longer, the bigger the molecule, the longer its chain is, the stronger, the bigger its surface area, the stronger its London forces. So this one's got the higher boiling point. I know this is not an accepted, but
You guys know.
in the science exams, but it's boiling point. So this one's got the intermediate boiling point.
And then the dimethyl propane.
And this one's got the lowest boiling point. And the melting points will follow the same pattern. to visualize this. You need to be able to visualize it. On page 119 in your textbook, you will find the properties of hydrocarbons. Please do yourself a favor and read through those bullets there. They are saturated hydrocarbons containing only single bonds. There are unsaturated, but I'm going to still look at them. Hydrocarbons form non-polar molecules and therefore they do not dissolve in water. Examples are petrol, Vaseline, candle wax, paraffin. They have low melting and boiling points because of weak van der Waals forces. The van der Waals forces, the specific van der Waals force here is the London force. Dipole forces are are van der Waals forces. Hydrogen bonding is van der Waals.
Non-metal forces. Yes, ma'am. That's what she said, because ion dipole forces on
Iron dipole forces are not van der Waals. So the moment you have an ionic substance, it's not a van der Waals force. You're right. As the mass of the molecule increases, the density, the melting point and the boiling point of the substance will increase because the van der Waals forces, the London forces will increase. So I mentioned boiling point and melting point, but density is also in here. So density, the density of the pentane will be much higher than the density of the dimethyl propane. Next, I want to talk about this. Vapor pressure. Vapor pressure is simply the pressure exerted by the vapor of a substance. Now, how does boiling point affect vapor pressure, or melting point affect vapor pressure? Water's got a boiling point of 100. Ethanol's got a boiling point of 78. So water, H2O, has a boiling point of 100 degrees Celsius at 80 P, at atmospheric pressure. But ethanol we're making nonsense here. CH3CH2OH has a boiling point of 78 degrees Celsius. Which one will have the highest vapor pressure? Which one will evaporate the easiest? The ethanol.
Yes.
The ethanol will evaporate with the greatest ease. So it will form more vapor than the water at the same temperature. Say the water and the ethanol is at 30 degrees. Which one will evaporate quicker?
Ethanol.
So it will have more vapor in the atmosphere. It will exert more vapor pressure.
So the weaker the London forces, the greater
The weaker the intermolecular forces, the greater the vapor pressure. So of the three molecules we were looking at, the pentane, the methyl butane and the dimethyl propane, which one will have the highest vapor pressure?
Dimethyl
This one will have the highest
Vapor pressure.
vapor pressure. Yes. So the lower the boiling point, or the lower the boiling point, the higher the vapor pressure. Let's go to the next one and see how you will cope with the isomers. So chain isomers have the same molecular mass, but they don't have the same strength, intermolecular forces.
Yes.
So the shorter the chain, the lower the melting and boiling points, as well as the densities. Because density means that the things, the molecules are pulling together tightly and closely. Yeah, obviously, if the London forces is weaker, then the density will be less. Right, go for, what's the next one?
The next one is hexane.
Hexane. Okay. Let's see how many isomers you can get out of hexane.
I only got 4, man.
We gotta move.
So the first one is just hexane.
Yes.
Uh-huh.
So I took one of the carbons and I joined it to the second carbon.
That's nice.
So this is a pentane, and it is 2-methyl
2-methyl pentane.
pentane.
And then there's
Okay.
also
Then I took that methyl and I put it on the third carbon.
Yes.
so now it's 3-methyl pentane.
So now it became 3-methyl pentane.
I don't see anything, man. Where's the difference?
Come closer. That one's on the C2, that one's on the C3. So it's weird.
Can I get a sticker?
So this one, I went from this one to that one by taking one of the carbons from the chain and
sliding it to C2.
putting it onto the second carbon in the pentane chain. Then I broke another carbon off the chain and I put it as a side chain. So there's 1, 2, 3, 4. So now I've got 2 methyls and the longest chain is 4, so it is a butane.
So man, it's just about switching the carbons then with the
Yes.
Oh, that's what I was so confused.
So this is 2, 3 dimethyl
And you could have
butane.
also-
Wait,
Okay.
yes.
I was saying, ma'am, there's also one where I think since you got the 2, the last one, since you got 2, you could also say 3,
No, you can't say 3.3
But you have
because
to
the
have
rule
the nearest.
is that you must number the longest chain so that the first functional group will be on the lowest numbered carbon atom.
Oh,
But man,
oh,
if okay,
So this can't be 3, you have to count from
that actually
the left hand side here. So this is 2, 2 dimethyl
methyl.
okay.
I did
butane.
something
I've
wrong.
got all of those, but that 2,3 dimethyl butane, because I didn't know you could go from C2 and then also put another one on C3.
Man, I did something.
So fix it.
No, I want you to come see it.
So they are chain isomers of hexane. Okay. All the ones that were made a shorter chain. So this one is a chain isomer of hexane. 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 Now within the chain isomers, listen carefully and look. What's the difference between the green clouded molecules?
The one
It's still pentane.
The one, the methyl group is on the second carbon, and the other one, the methyl group, is on the third carbon. So these two are called positional isomers.
Because it's the exact same thing, but just in a different position.
Are those the ones that have similar boiling points?
Yes.
So would that mean the 2.3 and the
Aha.
2.2 would also be
You're
positional
right.
isomers?
So these ones are also positional isomers because their chain lengths are the same, but the position of the methyl groups are different. So there it's 2 and 3, here it's 2 and 2. So these two are positional.
Isomers.
They are positional isomers. Because the chain length, the longest chain length is the same, but the position of the methyl groups are different. So they are called positional isomers.
Molecules, right? The hydrogen atoms are so close to each other, and they're like atoms. Doesn't that mean they repel each other since they're...
How big is a hydrogen atom compared to a carbon atom?
Minuscule.
A hydrogen atom has one proton and one electron, and most of them have no neutrons. A carbon atom has 6 protons and 6 neutrons and 6 electrons. So in my model, the model isn't even a fair comparison between the hydrogen atom and the carbon atom size.
Carbon.
So the carbon atom is like 6 times bigger than, or maybe 12 times bigger than the hydrogen atom. Yes, its mass is 12, where hydrogen's atom mass is 1. So the carbon atom is much bigger than the hydrogen atom, and you can see they space out. Even in my model, you can see that they are spaced out.
They don't have time to be pushing each other.
Okay. Let's go to the alkenes.
Wait,
Oh,
ma'am,
wow.
can you please...
Wow.
Yay.
So then that's it for now on the alkene.
You have an idea of how to do them now,
Yes.
how to play with the molecules. And although I didn't put the condensed structural formula, let's do it then.
Figure it out.
So it's CH3, CH, CH3 in brackets, CH2, CH2, CH3. Okay? This one is similar, it's just the position of the CH3 side chain that will be different. So what would that one look like?
CH3,
CH3, CH2, CH, brackets, CH3, CH2, CH3. And this one?
CH3,
CH3, CH,
bracket
CH3, CH,
bracket CH3,
bracket CH3,
CH3.
CH3.
Beautiful.
Poor board work. And this one,
CH3.
CH3, C,
Bracket
CH3, bracket 2, CH2, CH3. It's easy.
So then, what's the deck? Is it decane?
Yes, we
Okay,
won't
that's
go
So
there.
that's going to be very hard to boil then. 'Cause that's what
Yes, it's more difficult to boil.
It's not gonna
It's got stronger boiling intermolecular forces. Uko, just move your body. Unsaturated hydrocarbons. Unsaturated. Hydrocarbons means what?
They can still make
They
one.
still make more.
Yes, the carbon atoms have double and triple bonds between them, and you can add atoms to the molecule.
So that means that could they be polar?
No, they'll also be non-polar because they're hydrocarbons, so the only atoms in the molecule would be hydrogen and carbon. But now there is a double bond between two of the carbon atoms. The smallest alkene is ethene. What's the nature of the molecule?
Is a degree of polarity.
Yes, but the
Non-polar.
molecule, the
Non-polar.
bond is slightly polar covalent. It's a non-polar molecule, and the intermolecular forces between non-polar molecules would be London forces. Now this double bond site is very reactive. Ethene is much more reactive than ethane. When we do the reactions one day, we'll go into that. But the double bond is determining the homologous group, so, or family, or series. What's the next one? C3H4 is the molecular formula.
What's the general formula?
C2, sorry, C2.
Why would we jump from?
So now it's just 2N for this one.
You can't have what?
So man is the general
Wait,
formula
we'll
says
get
that-
there. We'll get there. Just give me a chance. You need to be careful here because we have the habit of putting two hydrogens. Just count the number of bonds that are already formed by the carbon. And then you just add the hydrogens to form 4 bonds. Each carbon must form 4 bonds. So this one's condensed formula is CH2, CH2. This one's condensed formula is CH2, CH, CH3. What is this?
Methane.
Propene.
I apologize for the interruption. Please note, periods 3 and 6 will be swapping. Shaggy can you come to the
That
office
means
at the
we
end of
don't
the
have
period?
math now.
Okay. Next one.
Next one is going to be butene.
Butene.
Ma'am, you see, won't this be polar? Because this
No,
is-
they're all non-polar.
I
They
don't.
weren't allowed. They don't want.
Okay, I'll build it now. Then you can see it.
Ma'am, the structure which you draw, it doesn't matter.
What do you mean?
So, the how on the ethene there the hydrogens at an angle.
Look at the
No, it's not that important, but let me build it, and you'll see.
So if they, like what I was thinking now, so if they say for carbon to have 2 bonds for the hydrogen, if they say it's 2 bonds, then it's better to do it at an angle.
Yeah. Oh, what happened to my books?
But could the hydrogens be on top of the carbon?
Yeah.
Oh,
What do you do in front of me?
Mama's homework.
What is homework?
What is homework? Homework is work to do at work.
Okay.
That is homework.
Can you try number 5 and 6 and 7?
On the same number.
5, 6 and 7.
I think
Page 121, 122. 5, 6 and 7.
Let's go to Miss Reynolds.
wait, let's do that experiment.
I mean, it's not even if it was coming at your forehead, there's no scaling.
I just want to show you before you leave, please, what the double bond does to the molecule.
I'm not told enough. No.
Stand on the chair. Don't be scared.
Okay, you see what the double bond does to the molecule. If you look at it like this, it's a linear molecule. But if you look at it like that, the hydrogens stick out because the basic structure is still the tetrahedral structure. So this is what it looks like if you have one butene. Okay? So the whole molecule, because of the zigzag effect of the molecule, the fact that there's no hydrogen there doesn't matter. The overall charge, the molecule is not found. Doesn't matter how you look at it, from which side you look at it, what is surrounding the carbons are the hydrogens, and the hydrogens make them non-polar.
Jugular, maybe razor.
But it jumps at you.
No.
But I have a question. Since have your double bonds between the carbons, how will you go about?
You can read up on it because don't worry about the isomers. We'll get there tomorrow.
Oh.
Yeah. She means we'll get there.
They said we'll get there, let's say tomorrow.
We're there.
No, just listen to this over. We are
Yes,
right.
this one is one butene, and there it will be 2 butene.
So it's not that hard.
Good. I'm trying to, ever since like school started, every day I try to go over what we've done.
What are you doing?
Like every day I try to go over, like after homework I go over everything we've done.
Yeah.
And then, even though like it keeps me up at night, I still
Yeah, you must listen to your body. If your body is very tired, you need to go to sleep. Otherwise you won't stay sane for very long. But pushing it a little bit doesn't work.
do like English last.
Oh my, English is so important.
Good. I think I'm right.
I always do like the maths.
Maths and physics
Yeah,
come
maths
first.
and physics are also
Because then my brain is still fresh.
Yes.
By the time I get to English and Afrikaans today,
Kan on, children. Let's get going.